All right, so today we're continuing in chapter 4, and we're going to do 4.2, graphs of exponential functions. So now we've kind of looked at, what exponential functions are. We know the a times b to the x and things like that. And so now what we're going to do is graph them. Now graphing is kind of hard because I can't draw straight lines or nice curved ones. But anyway, we're going to start with graphing exponential functions in the form the f of x equals just b to the x. So last time, we saw there was an a here. Well, all that a is a factor, and we're going to get to that in a little bit. But we're going to start with just the b to the x. And when we graph these kind of things, if we're doing it by hand, what we need to do is we need to create a table of points. And so usually 3 points is a minimum that I would do. And of course, your first point you can always get is going to be 0, 1, because when you plug that in here, 0, that's going to give you 1 for y. And so that's going to be a point for every b to the x problem you do, no matter what b is. So that's one. Then after you plot those 3 points, basically you draw a smooth curve through the points. At least you're going to try, because like I said, when you're trying to draw points, it's not that easy by hand. Nice and easy by calculator, nice and easy by Desmos and other things, but by hand it's not the easiest. And so as you can see, a lot of the graphs I've done are by Desmos, and then I copied and pasted them in here because I can't draw it to make it look nice and show you what it's looking like. And so with the b to the x, we have a domain. Basically, we're going from negative infinity to positive infinity. So if you think about it, we're going all the way out here. It's getting close to 0, but never touching. And then it goes all the way up here, and it just keeps going on and on to the right. And so the domain is the whole set of real numbers. Now the range, we don't get to 0, so it's going to go from, parentheses 0 all the way up to positive infinity, because this is just going to keep going and going and going. And then a horizontal asymptote, that's where it's never going to touch, and that's that y equals 0, basically. That's where our horizontal asymptote is. Now, when we're looking at graphs, we always go from left to right. So that's kind of going to be the key. And so when we have the largest b, that's going to give us the steepest increase. So when b is greater than 0, that's kind of the green line here. And the larger the b is, it's going to get closer and closer, just going almost a straight vertical, really close to the y-axis. Now, the smallest b is going to give the steepest decrease. So the b between 0 and 1, that's going to be a decreasing decay function for exponential decay. And the closer you get to 0, it's going to get steeper and steeper and steeper and go down like that. And so I kind of want to show you that with Desmos and how we can see that, if I can find where Desmos is. So what we have here is I've got basically our b to the x graphed. And so if we go negative, what happens is, 0.9 and 0.87. And as we go closer to 0, it just keeps getting steeper and steeper. So, it gets really steep the closer we get to 0. And then if we go the other way, the larger we get, it's going to get larger and larger, and it's going to get closer to that vertical axis as well, going up and down. So the larger the number, the higher it's going to go straight up, or closer it's going to get to that y-axis going straight up. And then the smaller, so if we would go to 0.001, it's going to be really close to that axis and then come down and go over here. So that's kind of what our b to the x function is going to look like. It's going to, be all those different values going as we go down, and then going back the other way, decreasing functions when we're going between 0 and 1. So that's kind of how the b's are going to work. And so whenever you see a decreasing function, you're going to have a fraction for b. And when you see an increasing function, we're going to have some b that's going to be greater than 0. Should be a 1 here, actually, but it's going to be greater than 1. So I better write that there. I don't know why I type 0, but I do some things like that. So that's going to be a 1. And so anything greater than 1 is going to go up like that. And it's always going to cross this point 0, 1. And so that's going to be a key, because that's going to be our intercept. And again, that's just for when we have b to the x. If we have a times b to the x, then it's going to cross at wherever a is. So that's going to be the key there. All right, so that's kind of what we have there. So what we're going to do is we're going to attempt to draw a graph here. And so I've kind of made a table, and what we're going to do is fill in the table. So they always say use that 0, 1. So if we plug in 0 for x, what do we get? Well, 2 to the 0 is 1. So that's going to be 1 point. Now we can just plug in some other points. It doesn't matter. Maybe we plug in a 1, and maybe a 3, so it's a little further away. Because if we start getting too many, then that's going to get really big fast, and so then your graph's going to have to go really high. So let's just do like 0, 1, and 3. We could do 1, 2, 3 or whatever, but 1 and 3 works. Well, if we take 2 to the first, and because we use x as 1, that's just 2. Now, if we take 2 to the third, because x is 3, that's going to be 2 times 2 times 2, so it's going to be 8. And so, again, we have our 3 points. We know that it's not going to go below the x-axis, and so we don't have to worry about that. And so now we just have to have some on the y, so we'll have a 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll go 1, 2, 3, 4, 1, 2. All right, so we'll have 0, 1, we know that point. And then 1, 2, so we'll have 1, 2, and that's not going to stay there, so we'll put it again. And then we'll have 3 8s, 1, 2, 3, and so then we'll have, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So that's about there. Well, not there. Now I lost my 8. So 1, 2, 3, 4, 5, 6, 7, 8. So somewhere about there. And so now we know the graph is going to do, again, this is the part where you're supposed to draw a nice smooth curve. And I missed the point, but that's okay. We'll make a big point there. All right. And so that's going to be kind of what our graph looks like. Again, it's a sketch. It's really rough. It's not that good. And you know, if we had graph paper, that would make it a little easier, but we don't. So this is going to be what we have. So now what is our domain? Okay. Well, the domain is all the x's. And so basically we're going from negative infinity to positive infinity. What about a range? Well, a range, we're not getting to that 0, but we're getting close. So the range is going to go from 0, and it's just going to keep going up. So it's going to go to positive infinity. And our asymptote is going to be just the y equals 0 here. And so that's going to be what our asymptote is. Now the key is we're going to get to transformations with exponential functions. And so, you know, our asymptote is going to change depending on, you know, shifting up and down. You know, our points are going to shift left and right as well. And we're going to flip over the axis, both the x and the y axis. So there's going to be a lot more things we're going to do. But with just the plain old, you know, b to the x, this is kind of what you're usually going to get. You're just going to have these 3 things. So those are going to be the case when you have a b to the x. All right. So that's, again, a rough sketch of 2 to the x. Now let's kind of think about this. Now this kind of goes back to what we learned last time, where the a, remember, is going to be our initial value. And we always said that was a, or 0, comma a. So that's going to help us do this kind of set of problems. And so we just have a jumble of you know, lines and curves and stuff like that. And so what we want to look at is which one's going to have the largest b. Okay, largest b. Well, remember, when the b is largest, it's going to be an increasing, so it's going to go like that. And when we have the largest, it's going to have the steepest going straight up. And so if we look at these, so it has to be increasing, so it's either going to be D, E, or F. And the largest one is going to be the steepest increasing. Well, if we look at that, that's going to be D, because it's going up the quickest compared to the other values, okay? Now the smallest, well, remember, the smallest one, they're going to be decreasing. So it's going to be some fractional thing. And if we want it to be really close to the axis, it's going to be the steepest at that point. And so looking at these, you know, we could have B, C, A are the 3 possible ones. And the smallest value looks to be C, because it has the steepest thing. It's going to keep going up, and it's going to be staying really close to that y-axis. Now the other 2 we have to think about, again, going back to our initial values. And so basically our 0, comma a. So the largest a, well, that's going to be the largest intercept. Well, where's the largest intercept? Right there. And so the one with the largest intercept is C. Now what's the smallest one? Well, that's going to be the one with the smallest a value, which is all the way down here. And that's going to be F. Okay. So they're going to have you do things like this where you have to decide the largest and smallest B's and A's. Sometimes they'll give you equations of the line and you have to kind of match it. So they might say, okay, well, um, they give you 3 or 4 different ones that look very similar, and then you just have to kind of based on the A values or maybe the B values, they're steeper, and then you just kind of go with that. And so it's all going to be something similar to that where you have to kind of base it on A's or B's and then go from there and choose which one best represents the graph. All right, so this is a kind of the first really broad overview of transformations that we're going to look at for our exponential function. So our base function is, or our parent function is just going to be our b to the x. So that's what our base is. And then what we can do is we can, vertically shift it up or down. We can shift it left or right. We can reflect it across the x or y axis, and we can, stretch it, make it go more steeper or more flat, depending on our different values. And so our first thing we could do is a vertical shift. And again, this is just an overview. We'll go into more detail on each of these in a little bit. So with a vertical shift, what we're going to do is we're going to end up adding a d to the original parent function here. So we'll have b to the x, and then we'll have plus d. So d can be, again, positive or negative, just like it was with our other transformations. And as we'll see in a little bit, if it's plus, we're going to move up, and if it's negative, we're going to move down. So nothing much has changed with that as far as how it worked with our previous transformations, which is really nice. Now, horizontal shifts, we're going to add a c constant, and we're going to add it to the exponent. So we're going to have b to the x plus c. And again, c can be positive or negative. If we have plus c, we're going to move left. And if we're going to have a minus c, we'll move right. So kind of like what we saw before. So nothing really changes there as well. We're going to have the same kind of things. So we don't have to remember something completely opposite of what we've learned before. Now we have stretches or compressions, and basically that's when we start adding our a constant out in front. So when we multiply by a times our b to the x, if a, the absolute value of it, is greater than 1, so basically 2, 3, 4, something like that, we're going to move up. We're going to stretch it vertically. And so, maybe we initially had the a was 1, like this, and then also we multiplied it instead by 3. Well, instead of being an intercept of 0, 1, it's going to be 0, 3. And so, we're going to be changing it based on that. And if we compress it vertically, what's going to happen is if we have something between, 0 and 1, so basically a is less than the 1 absolute value of it, well, maybe we have a third here. So instead of 1, we end up with a third, and so our value is going to be at 0, 1/3 instead of 0, 1. So it's going to be pushed down. It's going to compress it down into the closer to the x-axis. And then we have reflections. And so when we do it about the x-axis, well, we just take minus the whole function. So we just are going to put a negative out here, and that's going to reflect it across the x-axis. And if we reflect across the y-axis, we're going to change the exponent to a negative x. And if we think about that, it's really b to the negative 1 raised to the x, which is b to the negative 1 is 1 over b, then to the power x. And so, we can look at it either way here. This is the more concise way because then you can kind of see it directly. This one, you'd have to convert back to here to actually see what it meant. But this is, what we're going to do. We're going to take it to the negative x power. So let's start with our vertical and horizontal shifting. So if we put both of them together at one time, we'll have b to the x plus c, then plus d, okay? And again, like we said, when we have d units added, either if we add it, we're gonna move up, and if we subtract it, we're gonna move down by shifting. And so that part's gonna be our vertical shift, up or down. So depending on what that is. And then the c part, that's going to be basically your sign. So if it's a negative c, so x minus c, we're going to move to the right. And if it's plus c, we're going to move it to the left, okay? Now, what does this do to all of our different items? Well, for the y-intercept, now we have b to the c plus d. So it's going to change your y-intercept to this new intercept. And so we'd actually have to plug all that in, figure out what the new intercept is, and then that would give us our value. Now, the nice thing, the horizontal asymptote, that's easy. It's just whatever d is. So if we have a plus d, y equals then, maybe a 2. So then that would be what it was. But if we're shifting down, then all of a sudden maybe it's a negative 5. Well, then y equals negative 5 is going to be our horizontal asymptote. So it's going to be basically shifting up and down depending on what our d is. Now our range is going to be based on our horizontal asymptote and also based on that d. And so whatever our d is, that's going to be our lower limit, and we're still going to go up to that positive infinity. Okay, and so that's going to be a key here. Now this is just, if we don't have an a here. If we had a here, that changes everything altogether. But if we just have what we have here, just b to the x plus c, then plus d on the end of it, then our range just goes from that d to positive infinity. And in all cases, our domain basically stays the same as from negative infinity to positive infinity. So again, because I can't draw these very well, I just kind of copied some nice pictures that kind of represented what they show. And so we have our middle one here. This is where we start. So that's where we have 2 to the x. And so, that's our 0.01. And if we have 2 there, then it goes at 4. And it's off slightly, but it's still okay. And if we had 3, that would be 8, which is a little closer to being on. But that's going to be our curve. Now, if we shift left to right, let's say we have -3. Well, that's going to give us a negative, so it's going to shift right. And so what we do is wherever this was at, we move it 3 units to the right. So this is at a 1, so then we go 2 and then 3 at this point. So that's going to be the new point there. And if we shifted it to the left, we have that +3. And so we just move 3 units the other way. So we have 2, 3. And so that would be where that one is at there. So again, we're just moving left or right 3 units. And so depending on what point you're at, you just move left or right 3 units and plug it in. Okay. Now with the D parts, basically we're just moving up or down 3 units. So when we have +3, we've seen that many times. So if you start at 1, you move up 3 and you're at 4. And if we have a -3, we just go down 3 units. So we go down 1, 2, 3, and we're at the -2. And again, because we have +3, that's going to be our new horizontal asymptote. And so that is now at this point here, and that's our y equals 3. And this is being -3, that's going to be our new horizontal asymptote at y equals -3. So that means for this one, it gets all really close to 3, but it never touches instead of 0, where this one was. And then the orange line, it comes down and it gets really, really close to -3, but it never touches. And so it just keeps going out and getting closer and closer to the -3, but never reaching it. And then you could always, move all your other points down as well, 3 points to get to it if you're doing the orange, or you can move them up 3 points if you're going to the red if you added 3. So a lot of this stuff, we've seen before, so it's nothing new as far as transforming up and down. So let's just look at our graph here. So we want to graph this. Well, what is the base or the parent graph here? Well, the parent graph is just f of x equals 2 to the x, because we know we have the 2, that's kind of our base, and we have our x. And now what it looks like is we've, -1 in the exponent, and we've added 3 here. So this is going to be our c. This is going to be our d. So what does our c tell us? Well, it's going to be moving right 1 when we have x's. And this one's going to be moving up or down. Well, this is going to be moving up 3 for our y's. So if we start, now this is I just used the same points as we had before, 0. If we plug in 0 here, we get 1. If we plug a 1 here, we get 2. If we plug in 3, we get 8. So I'm going to start with our base parent graph. And then I'm going to add and stuff what we have here. So if I have the c going -1 here, that's going to be moving right 1. And so if I take the x and move right 1, well, I start at 0, now I'm at 1. If I start at 1 and move right 1, I'm at 2. And if I start at 3, move right 1, I'm at 4. So that's how I got my new x points. Now how do I get my new y's? Well, I'm going to move up 3. So I'm going to have 1 up 3 is going to be now 4. 2 up 3 is going to be now 5, and 8 up 3 is now going to be 11. And so now, and again, hardly good quality drawing, but that's okay. If we want good quality, we can always do it on Desmos or our calculator. All right, so our new graph is going to be at 1, 4 is going to be a point. So 1, 1, 2, maybe we should add another line there, another one there to make it even. 1, 2, 3, 4, so that's going to be that one. Then we'll be at 2, and then we'll be at 5, so that'll be about there. And then we'll be at 4, 11. So what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it's over at 4. So something like that. Okay. And so now we have kind of the general shape. Now, what do we know about our new horizontal asymptote? Well, it's going to be y equals 3. And so at y equals 3, we're going to have this horizontal asymptote. And so what's going to happen is we're going to have this graph that's increasing from left to right. And it's going to look something like that. Again, you know, drawing it by hand doesn't make it look nice, but that's what it's going to be. Now, our other one we had previously, we had the 0, 1, and then we had the 1, 2, and then we had the 3, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that was somewhere about there. And so then it was horizontal asymptote was at 0, and then we go up like that. And so that was kind of the original graph. And then the new one is when we've shifted up and to the right. All right, so what do we need now? Well, we still need the domain, the range, and our asymptote. Well, we know the asymptote is y equals 3. The range, well now, since that's our new asymptote, we know it's going to be at d comma positive infinity. So d was 3, and so that's going to be our new range is 3 to infinity. And our domain, well, we're still going from, you know, down here negative infinity all the way to positive infinity. And so that's going to be that. So that's our domain, that's our range, and that's our asymptote. Okay. And again, we just went and we had to kind of look and see what did our base function look like, which was just 2 to the x, and what did we do? Well, we subtracted 1, so that means we're going to move right 1, and we added up 3, so we moved up 3. Okay. So again, just using our transformations. All right, so we can also nicely use a calculator to estimate values. And so maybe on our graph, maybe we wanted to know what is, you know, the value where my pin is here. There we go. What is the value at this point right here? Well, our calculator lets us figure that out. And so what we do is we type our exponential equation into y1. So we, you know, we're going to graph. And so we plug that into y1. And then when it tells us, okay, well, what is the value of f of x, or what is our y we're looking for to solve for x? Well, we plug that into y2. And then we graph our function. Now we have to make sure a window includes the intersection point where the horizontal line in y2 is intersecting the exponential function in y1. And then we just use our trace button, second trace, and intersection, which is number 5, and we can find our intersection point. So let's do this one here. And I forgot to write it down, so I better write it down real quick, and then we can go and do that. So we have 4 equals 7.85 times 1.15 to the x minus 2.27. All right, so let's go to our calculator and show you how this works. All right, so we plug into y1 the original equation. So that was 7.85 times 1.15 and then raised to the power x. Now go back down, and then minus 2.27. So that's our y1. And we had it set equal to 4, and so we want to say that's equal to 4. Now, how's our window going to be? I don't know what it's going to be. So let's maybe go from -20 to 20, maybe by fives, and well, we don't need a minimum of -20. We can put it in though. So, all right. So now let's look at the graph of that. Okay. So this is our exponential function that we had on the blue line. And then the y is equal to 4 is going to be our red one. And so what we do now is we hit second trace, and we want the intersection of where they intersect. So that'd be number 5. Now we can just say, okay, yep, the first curve is blue, second curve is red, and I'm not going to guess anything, and I just click it, and it tells me at 4, this is going to be my intersection, -1.608. So let me write that down, -1.608. And so our answer over here is going to be -1.608. Tenths, hundredths, thousandths. That's all it gave us. So I don't know if that means it's exact or not, but that's going to be our solution to that one. And you can do that for basically any function. So what you do is you plug in your right side as your y1, your left side, whatever your y is, that's going to be your y2, and then you just do the intersection point. So you do your second trace, then number 5, and then you just hit enter until it gets to where you need to be, and then it tells you what your intersection is. In this case, it was the -1.608. Okay. So that's a nice feature again we have with our calculator. We can do some stuff like that. All right, so the next thing we can do is stretches and compressions, and this takes into consideration that A, their initial value, okay? And so what the A does is, again, we're going to stretch it vertically if a absolute value of it is greater than the 1. So it's going to basically push it up. So if we initially had, just 2 to the x, if we took it multiplied by 3, it's going to be all the way up here. It's going to multiply that 1 times 3 and get us a 3. Now, what if we had something between 0 and 1? So absolute value of A is less than 1. Well, then what's going to happen is it's going to push it down. It's going to compress it down. And so if we had 2 to the x as initially our red line, then if we took that times 1/3, which is between 0 and 1, then it's going to push it down. And so then that new intersection point is going to be 0, 1/3. And this one is going to be the 3, or 0, 3, sorry. 0, 3. Okay, so that's what our new point there is. And our original b to the x, it's always just 0, 1. So we don't even have to think about that. That's always 0, 1. And it's just when we have that a, it changes to what it does. So when you have a number greater than 1, then it's going to be, stretched, or it's stretched vertically. It's going to stretch it up, and otherwise it's going to be compressing it down if we have less than 1 but greater than 0. So that's what's going to happen there. Now, what does it do? Well, we know that the new intercept is 0, comma a, which is what we see here as well as here. And we still have our horizontal asymptote at y equals 0. We still have our range of 0 to infinity, and we still have our domain of -infinity to infinity. So those don't change. All that really changes is our y-intercept and the shape of our graph. So that's really the only things that change. The rest of the key items, asymptote, domain, range, they stay the same. All right, so let's sketch the graph of this. And basically what I'm going to do is I'm going to plug in a few numbers for x, get a few numbers out for y, and then draw it. So, if we go ahead and try to find what our intercept is, let's use x equals 0. Well, 4 to the 0 is 1, times that is a half, and that's what we expect because, again, that's our a, and 0a is always going to be our intercept, and so that's what we would hopefully get if we plugged everything in correctly. Now, what if we plugged in, I don't know, say 1? Well, 4 to the 1 is 4, times a half is 2. So that doesn't work too bad. Now, maybe, I don't know, if we use 3, that's going to give us too big an I. Let's just use 2. because 3 is going to give us way, it's going to be kind of off of the scale what I can actually draw and make it look nice. So 4 squared is 16 divided by 2. Well, that's 8. All right, so let's go ahead and try to draw this. And so 1, 2, 3, 4, 5, 6. And then we have, all right, so 0, 1/2. So that's about right there. 1, 2, that's about there. And 2, 8. So that's going to be about, about there. Okay. And so it's going to have pretty steep graph, but then it's going to keep going over here, never get to the 0, but get close. And so our domain, well, that's not going to change. We're still going to go from negative infinity to infinity. Our range, well, that's not going to change either. So it's going to go from basically 0 to infinity. And our asymptote, that's not going to change. That's still going to be y equals 0. So the only thing that really changes from our original graph, and our original graph, remember, is just 4 to the x. And so all we've done is take it times this stretch factor of 1/2. And so that does what it does. It takes everything to 1/2. So it's going to go down. It's compressing it down. And that's what we have there. Okay. All right. So the next one are reflections about the axes. So like I said, when we have a negative b to the x, what that does is it reflects it about the x-axis. And if you think about how that works, if this is our original equation, again, y equals 2 to the x, or f of x equals 2 to the x, what we're going to do is we're going to go through that 0, 1, and then we're going to go through points along the way going up there. And then if we take and change it to a negative, well, what it's going to do is our x's are initially going to stay the same, so those don't change, but it's going to make everything on y's go to the other side. So it's going to reflect it across that x-axis. So if we had a 1 here, it's going to become a negative 1 here. If at 1 we had a 2, at 1 is going to now become a negative 2 because we're changing the sign of what our y output is. And so basically, you get this nice graph going across the x-axis, and we have our red one versus the blue one. Now, what does it do with everything? Well, our domain for our new graph, the minus 2 to the x, it's going to go, still from negative infinity to positive infinity going on the x's. Now, what about our asymptote? Well, it's still going to be y equals 0, so that doesn't change anything. And our range, well, our range does change though, because now before we were going from 0 up to positive infinity, and now we're going from basically down here, negative infinity, all the way up to the 0. Now we're not including that 0, but our new range is from negative infinity to 0. So that's what changes when we have that negative out front. So the range changes. Our intercept also changes because, like I said, if we had 1 here, the opposite of that is -1, and so that changes. But this is the same, and this is the same. So nothing changes there, just those two items there. Now, if we're going to reflect about the y-axis, what happens is we're going to raise it to the power -x, okay? And that's going to reflect our original b to the x across the y-axis. So now we're going to go from left to right. And so what happens here is, if we initially had 2 to the 1, that's going to be 2. And so that was here. If we had 2 to the 1, so that's going to be right there. Now if we say, okay, well now that's going to be -1, well 2 to the -1 is not going to be there. And so what we're going to have is it's going to reflect it over here, and we have to have a -1 is going to be the 2. Okay, and so basically we're just changing the sign of whatever we plugged in. If we had a 1, it's going to be a +2, but now we're going to plug it in and make it a -1, and then that's going to be a 2 as well. Okay, so that's kind of what we're doing here. We're kind of decreasing as we go instead of increasing. So that changes how the function works. And this one, went from increasing to decreasing as well. Now, does anything else change? Well, as you keep going across, basically you just, keep going across and across and goes up and goes up. And so we're still going from 0 all the way to positive infinity for our range. So nothing changes there. We're still going from negative infinity to positive infinity for our domain. So nothing changes there. We still have that, 0, 1 intercept. And so nothing changes there. We still have this horizontal asymptote at y equals 0, so that stays the same. So nothing changes except for the shape of the graph. So all our domain, range, asymptote all stays the same, even though we've changed this to a negative x from the positive x. Okay. So let's kind of start looking at the kind of how we can use this. And what we're going to do is we're going to find the graph in the equation for the function g of x that reflects this function about the y-axis. Well, how do we reflect this about the y-axis? Well, g of x basically is going to be 1.25. Now across the y-axis, we have to change this to a negative x. Okay. So, and what we want to do is we want to graph both of them, and then we want to kind of see what that does. So if we plug in our original function and we plug in a 0 for the original f, what we get out is 1. Okay. Now if we plug in a 0 here, what do we get out? Well, guess what? We get a 1 as well. Okay. Now let's plug in x is equal to 1 and maybe, I don't know, 2. Just to make it simple. So if we plug in a 1 here,
You cut out. We can't hear you.
all right, hopefully I'm back. All right, so now we have to plug in a 1 here. And so what happens to that? That's going to be 1.25 to the negative 1. And so, what we're going to do is we're going to start getting really small numbers. And so 1.25 to the negative 1 gives us 0.8. Okay. Well, if we plug in a 2, it's going to get us even smaller because remember when we had our graph, now this is just kind of a rough one. When we initially had this one, that's what that's going to do. And we reflect across the axis. Hey, I hit the 1 there. It's going to go that way. So if we keep going positive, it's just going to get smaller and smaller. So you know what? We should probably go negative. Okay. So now let's go maybe negative 2. So if we go negative 2, what happens? Well, that's going to become a positive 2, and that tells us it's going to be at 1.5625. So the only different one we have is we went to 1 and we got the 0.8. If we would have gone to negative 1, we would have got the 1.25 because the negative negative is going to be a positive 1. And so now let's kind of graph our two functions here. And probably what I have hand drawn for Scratch over there is probably better than what's going to be here. All right, so let's say we 1, 2, 3, 1, 2, 1, 2. All right, so 0, 1 is going to be a point for both of them. And then we have 1, 1.25. So, again, this is all going to be estimates. And then at 2, it's going to be 1.6. So it's going to be, somewhere there. And so what do we have here? If we plugged in a negative 1, That's going to be a 0.8. So that's going to be somewhere here. And so this is going to be kind of going like something like that, very slow. Now plugging in the other way, we got 0, 1, and then we had the 1.8, so it's going to be about there. And then we know at -2 is going to be about 1.6, so it's going to be about there. And we also know if we plugged in the -1, we're going to get 1.25, so that's somewhere about there. And so now, again, it's going to look something like that. So this is our f of, that's our g of x rather. I forgot I changed names. All right, so this is our g of x. This is our f of x. And so what we want to know is the domain and range and asymptote. Well, our asymptote's still going to be that there line there. So y equals 0 is the asymptote. Now, no matter which way we look at this, the domain, the range, those are going to be the same. The domain basically is going to be from -infinity to +infinity. And our range is going to be from basically the 0, our asymptote, all the way up to +infinity. Okay. And so no matter what we are given for a function, we can find different things. We can reflect it across the y-axis. If we reflected it across the x-axis, it would just be a negative 1.25 to the x. And so all kinds of things we can do with reflections, shifting it up or down, shifting it left or right. And so this one is going to be what we do when we shift kind of up and down, left and right, and all those things. And so our initial function is f of x equals e to the x. Okay. Now we want to compress it vertically by a factor of 1/3. So when we compress, let's go ahead and leave off the f of x and equals. We'll start with e to the x. And if we're compressing vertically by 1/3, that means we're going to multiply by 1/3. So that's going to be our new a. Okay, so that's going to, what happens is it's going to be our a. And if we think about it, it's going to be pushing it down. So if we were initially at the, wherever it was, e to the x, looks like that. If it was like that, we're pushing it down here to 1/3. And so it's going to be something like that. But that's not all we're doing. We're also going to reflect it across the x-axis. Well, when we do that, everything's going to be shifted down. So if we keep our 1/3 one, that's a third there. It's supposed to be a third anyway. When we reflect it across there, that makes this a negative. And so we put the negative out in front. And then what we want to do is we want to shift it down 2 units. So to shift it down 2 units, we're going to subtract 2. Okay. And so now we've done all the things it's asked for. So now if we have a new function g of x, that's going to be that. And so now what we have to do is shift down 2 units. And so that would be our new thing. So we're going to say that's 1, 2 units. Okay. So that would be our new function because it asks for a new function. Now what else does it ask for? Give the horizontal asymptote, the domain, and the range. All right, so from here, we know that this is going to be our horizontal asymptote. So y equals -2 is the asymptote. So that was pretty easy. Now, because of that, we know that we're going to go, and again, it's not a very good shift down. Let's see, wait a second, y equals 2. Yeah, because it's actually a little lower, so that's going to be like that. So my shifting line marks are not quite right because that was 1, we shifted down 2, and so that would be actually the 2 there. So that's, my drawing again is not the best in the world because this is going to be at the -2 1/3. Because we had it -1/3 here, shifted down, so it's -2 1/3. So it's going up to the -2, and it's going from -infinity all the way up to that -2. So we're going from negative infinity to -2, and that's our range. Now, what is our domain? Well, our domain, we're still going from left to right the whole way, all real numbers. And so that's from negative infinity to positive infinity. Okay. So any questions on that? And so that's really the whole gist of this section. It's just, again, shifting up and down, left and right, and then compressing vertically or stretching vertically, depending on if you have, a between 0 and 1 or a greater than 1. Okay. So any questions up to this point here? Okay, so that's all I have for you today. I can do some more examples if you would like me to, but again, the key thing is I think being able to go from the written expression here to a new function, and then maybe finding the range, the domain, and the asymptote are going to be the key things to be able to do. Because if you can go from this, then you know how to get to this. You can easily graph that because you're going to start with your e to the x, and then we're going to do the negative, so it's going to reflect it over the x-axis, and then it's going to compress it by a third, so it's going to push it up towards the axis, and then we're going to drop it down too. So that's all the things we kind of did here. We didn't do it exactly in order, we just followed what it said. We did the factor of 1/3 first, so we dropped it down to the 1/3 and pushed everything down by 1/3, and then we reflected it across the axis, and then after that we shifted everything down 2 units. So kind of like that order. And so as long as you can do things like this to get it to this equation, or what we can do also is they can give you a graph and say, okay, here's a graph, what does it represent? And so then you kind of have to see, okay, well, what's the base function, and figure that out, and then after that determine your compression or stretch. Has it been reflected across the x-axis or the y-axis, depending on where it's at, and then up or down, based on that. And so that's going to be another thing that they could ask you for. Sometimes they'll say, okay, hey, your base is f of x equals 3 to the x, and then you have to figure that out based on the graph. So that's kind of a thing you have to do. And so you have to say, okay, well, it's been flipped, and so it's going to be a negative, and you have to kind of see what the new intercept is. So your 0a, and so whatever that is going to be your a out in front of here, and so that will be a negative a times your 3 to the x. And then because it's been flipped, you originally were down here, so then you moved up, so you have to figure out how many you've moved here from all the way down here, and so then that's going to be plus some d value. So that would be kind of how you would do something like that. Okay. So any questions? I think it's the first time I've been on time for finishing a class.